Hello viewers. In this example, with the given information, we are to find the method of moment estimate for theta. Now, in the moment method of finding an estimate, remember that definition of moment is nothing but expectation of x or expectation of y. And expectation of x, it has been proven that the same thing as y bar. At the same time, it is the integral from a to b of y f of y dy for a continuous function. So, in this example, the method of moment for the estimate of theta will have expectation of y is equal to integral from the interval is 0 to 1 of y. And our function is what? Theta y to the power of theta minus 1 dy. So this could be simplified as expectation of y is equal to integral from 0 to 1. Multiply this y by this y, we will have our theta, the same base, so this power 1 we add to this is theta to the power of 1 minus 1 dy. The same thing as just integral from 0 to 1. We can bring out theta, it is a constant. Then the power here becomes y to the power of theta dy. So we are having expectation of y as theta integral from 0 to 1 of y to the power of theta dy. Evaluate this integral. We are going to have theta. For the integral, we are going to add 1 to the power and divide by new power. So the power is now theta plus 1. So we divide by theta plus 1. Then we put the limit, the lower as 0 and the upper as 1. So this is going to be theta. Putting the upper limit, we are going to have 1 to the power of theta plus 1 all over theta plus 1 minus lower limit 0 to the power of theta plus 1 all over theta plus 1. So we are going to have theta. This side reduced to 0. Here we have 1 to the power of theta plus 1 is still 1. 1 to any power is 1. So we have all over 1 plus theta as our estimate of y. So recall that estimate of y is the same thing as y bar. Therefore, we'll have y bar, which is mean of y, the same thing as theta all over theta plus 1. Let us cross multiply this equation. We'll have mean of y into bracket theta plus 1 is equal to theta. To expand the bracket, we are going to have theta y bar plus y bar is equal to theta. We are finding theta, so let's collect like times. We'll have theta. If this one moves, we have minus theta y bar, and here we have y bar. Theta is common, factorize theta. Here we have 1, and here we have minus y bar is equal to y bar. And finally, we'll have theta is equal to y bar all over 1 minus y bar. So y bar is 0.42 plus 0.10 plus 0.65 plus 0.23 all over 4. We add this, we'll have 1.4 all over 4. So y bar is equal to 0.3. 1.4 divided by 4 is 0.35. Therefore, our estimate now will be y bar, which is 0.35 all over 1 minus y bar minus 0.35. So the estimated value is now 0.35 all over 0.6. So the theta estimate is 0.538. Okay, we have this information. Use the method of moments to estimate theta in the PDF, and this is the PDF given to us. It is assumed that the sample size is n. So as usual, by definition, moment is expectation of y. So expectation of y, we say is equal to an integral from the interval here 0 to 1 of y f of y dy, and also expectation of y is equal to y bar. Let's simplify this. Integral from 0 to 1 of y dot f of y dy is equal to integral from 0 to 1 of y dot, we have theta square plus theta, then y to the power of theta minus 1, then y minus theta 1 minus y dy. So theta square plus theta is a constant. We can bring it out of the integral sign. Then we have integral from 0 to 1. This y multiplied by this y, we employ loss of indices. Here we have power 1. With this minus 1, we are just having y to the power of theta. Then y minus y dy. So simplify this further. We have theta square plus theta integral from 0 to 1. Y to the power of theta times 1 is still y to the power of theta. Now y to the power of theta times y, the same base, this power 1, so we add the power. So we have minus y, then theta plus 1 dy. So expectation of y is equal to theta square plus theta. The integral of this is going to be y theta plus 1 all over theta plus 1. Add 1 to the power and divide by the new power. On this side, we'll have minus y theta plus 2 all over theta plus 2. Add 1 to the power and divide by the new power. Then we put the limit from 1 to 0. Simplifying this, we have expectation of y is equal to theta square plus theta. If we put the upper limit, wherever we see y, we put 1, we'll have 1 to the power of theta plus 1 all over theta plus 1 minus 1 to the power of theta plus 2 all over theta plus 2. This is putting the upper limit minus the lower limit. The value of lower limit here is 0. So if you put 0 here, we will have 0. If you put 0 here, we have 0. So the value for the lower limit is 0. So we can just reduce our work to this. This is going to give us theta square plus theta. 1 raised to any number is 1. So we have 1 all over theta plus 1 here. Minus the same thing here, we are going to have 1 all over theta plus 2. So simplify this. We are going to have it as theta square plus theta. 1 times this factor is theta plus 2 minus 1 times this factor is theta plus 1 all over this factor times this factor. So we have theta plus 1 and theta plus 2. This can be simplified as theta square plus theta. Opening the bracket, theta minus theta will go 2 minus 1 is 1. So we have 1 all over theta plus 1 and theta plus 2 is equal to expectation of y. So simplify this here, theta is common. We'll have theta into bracket, theta plus 1, right? Simplify this. Now into bracket we have 1 all over theta plus 1. Then in another bracket we have theta plus 2. That means our expectation of y is equal to theta plus 1 will cancel theta plus 1. We'll have only theta all over theta plus 2. Okay, we have expectation of y the same thing as y bar, mean value of y. So replacing this one, we'll have y bar is equal to theta all over theta plus 2. Let's simplify. We are going to have theta plus 2 multiplied by this value is equal to theta as the result of cross multiplication. Expand the bracket, we'll have theta y bar plus 2 y bar is equal to theta. We collect like times, we'll have 2 y bar is equal to theta minus theta y bar. So we have 2 y bar is equal to theta is common. Factorize theta, we have 1 minus y bar. And to find theta estimate now, we divide both sides by 1 minus y bar. So we have 2 y bar all over 1 minus y bar. So this is our estimate. And this brings us to the end of the class. Thank you for viewing. Have a nice day and please subscribe and personalize.